Hello, welcome to my YouTube channel today. Today's video is a continuation of my bus controller project for V30 processor or 8086 processor. Let me just boot this up real quick. We've got our main board, VGA, RAM, and ROM. Let's turn this so you see the screen. And you can see that it initialized the VGA card, so it's talking to the ISA bus. And that's kind of the step we're on now. So, turn that off. So, on this board, I've got a V30 processor here. This next row is latches and some transceivers. I've got interrupt controller, a system timer, bus controller ROM, a I/O decoder ROM over there, and then some logic. So the way this is working right now, your top latch here, I'm going to kind of go backwards, is A16 through A19 along with bank high enable latch. The next latch is A8 through A15 transceiver, and then the bottom latch is A0 through A7. This transceiver here is D8 through D15, and it's right next to this latch because they share, coming off the processor, the same pin, and that's why they're next to each other. Transceiver here is D0 through D7, and then there's a latch over here that's also D0 through D7. So the way this is working, connected to the ISA bus, you've got the data wires here that come over to the latch. Now this is only an 8-bit bus, and you can see it's going to the high side as well. This is all decoded. So it comes over here, then it ribbons over here to the low side and the latch. And through manipulating the enables on the transceiver and the direction pin, you can decide if you want just to talk to the high side, so A8 through A15, the low side, D8 through D15, the low side D0 through D7, and the latch is for reading 16-bit reads into the processor. Writing 16 bits out, you don't need to latch it. So a 8-bit read or 16-bit read would go A0, which is coming off the bus controller. A0 is fed into the bus controller. So A0 on the ISA bus is not off of the latch, it's off of the bus controller. So A0 is read into the latch, it's latched, and then coming off the latch, it goes into the feed side of the processor on the low side. And then you increment A0 up to A1 and do another read, and it's displayed on the wires, and then you enable this latch, and it feeds into the high side, the D8 through D15. And then you tell it it's complete, and that's how you read. So that you need the latch for reading. Writing, you just display it out on both transceivers. You enable the low side and you write it out, and then you enable the high side and write it out. So this is a 16-bit processor on an 8-bit ISA bus, which is necessary for compatibility. Now 16-bit reads, this is not set up for it, but it's actually pretty simple to have a 16-bit ISA. I just need one more transceiver to make it happen. Where we're at now with the project is I can't say for sure that the interrupt controller is working or the system timer. I think, I'll go through some boots here. I think that I've got the clock going into the system timer. It's actually twice as fast as it should be, but it shouldn't be outside the tolerance of the chip. But I think when this is connected, it boots slower, which would indicate that the system timer is working and the interrupt controller is working. But that's what the next step is, making sure these two work correctly, and then I should be able to start putting this onto a PCB, and then that'll eliminate all the potential errors of this big bundle of wires. So let's turn this back over to the screen, and I don't know if you want to look at the timestamp on the video. I'm going to turn it on. This is, so it took about that long, and then I'm going to take the click, I'm going to take it off the system timer, and it took about that long. It felt about the same. Let's try it again. This is with the system timer. I don't know, I think that was kind of slower. This is without. So anyway, that's where the next step is to get that interval timer working correctly and making sure that the interrupt controller is working. So anyway, thanks for checking out my video today.